As you can see, there we have our PIC16F877A, and here we have our 4 relay module. Now see, we have programmed it in such a way that the first relay turns on, then after 1 second the second, then third, then fourth, see, then second, then third, then fourth, and then they start to turn off one by one, fourth, third, second, and first. So this is how we programmed it. Let me show you the programming. So in the programming, you can see that we just initialize all the 4 pins of the PIC. Then by default, they must be off because it's an inverted logic. 1 means the relay is off. So then we turned them off one by one, and then we turned them off one by one. Simple. So this coding gives us this result over here. Welcome to learning microcontrollers. In this video, I'm going to show you 4x relay module interface PIC16F877A. So we will be interfacing a relay module having 4 relays operated at 5 volt with a PIC16F877A microcontroller. So this is our PIC16F877A microcontroller. We are going to use its 40-pin DIP version. This over here is the 4 relay module easily available in the market. As you can see, the relay is rated to be 5 volt. You can see that it says SRD 05 volt DC. So it's a 5 volt relay. So that's a great thing to have. So it's a 5 volt relay operated at 5 volts. So for this, we do not need any external power supply. And there you can see a jumper. Remember that, just connect this jumper directly, because it is like connected. If you connect a jumper, it means that this VCC, the VCC given here, will also go to the triggering coil of the relays. So the triggering of the relay is at 5 volt, while our microcontroller, that is PIC16F877A, also operates at 5 volt. So we will be inputting 5 volt to the PIC. We will also share the same 5 volt for the relay's triggering as well. So the triggering of the relay do not require a lot of current. It's just like 5 to 10 milliampere, or at max it will be like 20 milliampere. So it's not an issue. So you have to connect this jumper. Because I have connected this jumper, I will power up the relays. I will trigger the relays using the voltage of the PIC. So if you want to use an external power source, like you don't want to use your microcontroller source because microcontroller operates at 3.3 volt or something, then you have to connect an external power source of 5 volt to trigger these relays. So that is the story of this jumper. Rest, we have pins over here, and we have the relays outputs as well. So here we have the K1 relay, this one. K1 corresponds to the IN1 pin. So if the IN1 pin is pulled low, because these optocouplers are inverted, like if you give 0, then it means a 1 is sent. So you have to pull the IN1 pin low to trigger the K1 relay, and you have to pull the IN2 pin low to trigger the K2 relay. You have to pull the IN3 pin low to trigger the K3, and similarly for the K4, the IN4 pin. Now guys, let me show you the pin out. So we do the connection and then the programming. So the top pin, as you can see, is labeled as well, is the VCC 5 volt. The next one is the IN4, input 4, input 3, input 2, input 1, and the ground pins. Let's do the wiring. So the VCC pin, you directly connect to the VCC pin of the PIC16F877A, and the PIC16F877A will be connected with the PIC at 3. I will use that to power up the PIC as well. So that same source will also be responsible, because we will be having a jumper here, will be responsible to power up the relays triggering coils. So for the ground pin connected to the ground of the PIC like this, for the IN4, IN3, IN2, IN1, you can use any available digital input output pin of your PIC. I'm going to use the pin number B0 for the IN1, pin number B1 for the IN2, pin number B0 for the IN1, B1 for the IN2, and B2 for the IN3 of the relay module. And for the IN4 pin of the relay module, we will be using the B3 of the PIC. In this way, our connections are completed, simple as that. So let me introduce you to the hardware before we move on to the programming. So guys, this over here is our hardware. As you can see, it is same relay module as shown in the presentation. The wiring is as shown in the presentation, and we are powering up the PIC using the PIC at 3. This is a simple hardware setup we have over here. So guys, let's start the programming. So open the MikroC for PIC, whichever version you have. I have this 7.6.0 version, easily available in the market, or sorry, easily downloadable. So whatever the latest version is, you may use that. So I also have a lecture on this, how you download and install this for free from the official website. So do check that out. So okay, let us start up. Okay, here we go. So let me zoom in so you guys can see better. So on the top left corner, you have this file. Click on new. new project. This window pops up, new project wizard, click on next, write the name of the project, 4 relay module tutorial PIC16F877A by learning microcontrollers. Like this is the name I wrote, and the device is PIC16F877A, and the crystal I have on board at the pin number 13 and 14 of the PIC16F877A is 20 megahertz. Click on next and finish. So guys, here we go, the window. First of all, before you do anything else, press Ctrl S or click over here to save your work. That is very important. So save it. Now it's saved. Now first of all, we initialize the pins that we are using. We have 4 pins, B0, B1, B2, B3 for the 4 relay pin, for the 4 relays of our relay module. So I write trace B.F0 equals to 0. Now this command over here, let me zoom in further. This command over here traces the name of the direction register. It defines either the pin is to be declared as input or output or the whole port. So the pin number B.F0, that is pin number port B, pin number 0 is 0. 0 means it's an output pin and 1 means it has been declared as an input pin. So we are declaring pin as output. So copy this, paste it 4 times for all 4 pins, 1, 2, 3, 4. So B1 has been declared as output, B2 as output, B3 as output. Now the initial state of the pin, we know that this module works in an inverted way. So if you send a 0 to the port to this pin, it will trigger the relay, and at 1 it is not triggered. So by default our initial state should be high. So all the pins must be high by default. So I say port B.F0 equals to 1. So the first relay is off because 1 means off. 1 means it's off. That if the pin is high, it means it's off. So we just copy paste it to give the initial state. So this is the initial state, B.F0, F1, F2 and F3. By default, all the 4 relays are off. Now we write the forever loop while 1. Forever loop starts here and ends here. In the forever loop, just copy this. We change the initial state. We make the first relay to go on. Now first relay is on, and then we give a delay. We write a random code of like 1 second. Now after 1 second, it will turn on the second relay as well, like this. Oh, sorry, paste it here like this. Now the second relay is on. Now copy the delay. Again, we give a delay of 1000 millisecond or 1 second. Now do it for the rest of the 2 as well. Just paste it here like this. So first relay turns on, then there is a delay of 1 second. After 1 second, the second relay turns on, then the third relay turns on after 1 second, then the fourth relay turns on after 4 seconds. Then what happens? It will go off in the opposite sequence. So we write the code. So now the first relay will go off. Okay, the fourth relay, we start from the fourth. So we make it F3 goes high, goes off, then the F2 goes off, then the F1 goes off, then the F0 goes off. So our code is like this, that as soon as we turn on the power source, the first relay will turn on, then the second, then the third, then the fourth, after 1 second delay. Then similarly, they will start to go off, the fourth first, K4, K3, K2, K1, K0, and then it will keep on repeating. So I save, I press build to see if there is any error. There is no error. That's perfect. That's perfect. Now turn on the PIC3 programmer tool to do the program, or to burn this into the microcontroller. The PIC3 programmer tool has turned on. Okay, that's great. PIC3 is found. Click on PIC, select your microcontroller, PIC16F877A. I also have a video on that, how to download and install this PIC3 programmer tool. So do check that lecture as well. So click on file. Now import the hex file that you just created. This is the file. Double click. Now click on write for the code to be written. So the code is being written. We see the hardware over here. You can see that it is writing the code. Wait. It is programming the device. Just wait for it to program. Okay, the programming is done. Now we power up the circuit using the PIC3. So click on to power up the circuit. Now see, it start from 1. See, that is what we just programmed it. That is how it is supposed to work. See, the first relay turns on IN1. See, IN1 on, then IN2, IN3, IN4, and then from 4 it starts to turn off one by one. So these are your normally open, close and COM pins over here. You can just connect anything here, and the rating of the relay is very good. It can hold up to 10 ampere of 220 volt AC, like it can go up to 2 kilowatt of power. So guys, this is it. If you guys have any queries, you may ask. So this is the end of this lecture. I hope you guys learned something from this video. Thank you very much for your time, guys. We'll see you in the next lecture.